Hello everyone, this is Mr. Tanner, and we're going to be looking at the assignment, What Happens When Two Continents Collide today. For day one, we have one vocabulary term. It's converge, which means to come together, to move toward one another. What happens when two continents collide? The most dramatic transformations of our planet's surface happen at the boundaries of the tectonic plates. As the plates move and interact, they constantly change shape. Crust is created, destroyed, or simply reformed depending on the type of boundary between them. There are three types of boundaries: divergent, transform, and convergent. A divergent boundary occurs where two plates move away from each other. Here, new crust is created as lava seeps out of mid-ocean ridges. A transform boundary occurs where two plates slide past one another in opposite directions. Crust is neither created nor destroyed at a transform boundary. A convergent boundary occurs where two plates converge and one sinks under the other. Crust is destroyed along these boundaries as the sinking plate descends into the mantle. When two converging plates are carrying continents, a collision is only a matter of time. And here you can see the pictures of the three types of plate boundaries. Divergent has boundaries moving, or the tectonic plates moving away from each other. The transform boundary has the plates sliding past one another. Then we have the convergent boundary where the plates are coming together, and then the oceanic crust is subducted beneath the continental crust. All right, answering our questions here. Write divergent, transform, or convergent. So every answer is going to be one of those three words. Write divergent, transform, or convergent to name the type of boundary that fits each description. 1. One plate sinks under the other along this boundary. That only happens at our convergent boundaries. So this is convergent. New crust is created along this boundary. New crust is created where that magma seeps up through the rifts in a divergent boundary. One plate slides past another along this boundary. That is describing our transform boundary. Two plates spread apart along this boundary. They spread apart at divergent boundaries. And continental collisions occur along this boundary. Collisions are convergent boundaries. For day two of What Happens When Continents Collide, we have two vocabulary terms: buoyant, which is able to float or rise, and subduction, a geological process in which one plate is forced below another. When two plates converge, what happens next depends upon the composition of the plates. Remember that tectonic plates are made up of the lithosphere, which contains the crust. There are two types of crust: continental and oceanic. Continental crust is made of thick granite, a lightweight volcanic rock. In contrast, oceanic crust consists of a thinner but heavier volcanic basalt. A plate may contain continental crust, oceanic crust, or both. When the oceanic crust of one plate meets the continental crust of another, the oceanic plate sinks beneath the continental plate. This is because basalt is denser than granite. The process, called subduction, also occurs when two oceanic plates meet. In this case, however, the older plate is subducted below the younger plate. Again, the older plate is subducted below the younger plate because the older plate is colder and therefore denser. When two continental plates converge, neither plate can be forced below the other because both are too buoyant. Instead, they collide. Answer the questions. When two oceanic plates, which plate gets subducted and why? The older plate is subducted because it is colder and denser. And again, it's more dense because it is colder. Why does oceanic crust get subducted below continental crust rather than the other way around? Oceanic crust is subducted because it is denser than continental crust. When two plates with continental crust converge, why are neither of them subducted? Continental crust is not dense enough to be subducted. And then looking at that vocab, it is too buoyant. Which would take up more space, a pound of granite or a pound of basalt? This is like asking that question, what's heavier, a pound of feathers or a pound of gold? And it's, of course, a trick. They both weigh a pound. But if you think about this, the pound of feathers is going to take up way more space than the pound of gold. A pound of gold is going to be relatively small. A pound of feathers is a lot of feathers. And that's because the feathers are less dense. So the object that is less dense will take up more space if it's the same weight or the same mass. So in this one, it's saying there's a pound, right? The mass is a pound of granite and basalt. Which one would take up more space? Well, granite is less dense than basalt. You need to have a larger volume of granite to have the same mass as you would of basalt. So the answer here is granite takes up more space because it is less dense. Moving on to day 3, we have 2 vocabulary terms. We have fracture, which means to break into pieces, and we have sediment, which is sand and other small particles of rock. Before two continents collide, the ocean between them slowly disappears. The seafloor gets subducted into a trench that runs along the boundary between the two plates. As the seafloor is subducted, the two plates scrape against each other. This causes seafloor sediment to collect in the trench. When the oceanic crust is completely subducted, the trench collapses, and the marine sediment is forced up onto the approaching continents. As the continents collide, the crust of the two plates begin to buckle and fracture. Much of the continental crust is thrust upward, rising into peaks that over millions of years form mountain ranges, extending the length of the border between the continents. There's a simple set of 3 pictures here that shows two continents colliding. We start with oceanic crust colliding. So we have oceanic crust here and oceanic crust here, and as they collide, sediment builds up. Further along in time, these continents are still moving closer together, but the continents have not collided yet. That sediment continues to build on the ocean floor, and when the continents ultimately do collide, we end up with sediment, ocean sediment, at the top of that mountain. So we often see like marine fossils at the top of mountains because of this process. Question A says, the events below describe how continental plates converge. Number the events in the correct order. So our options are: the seafloor slowly sinks into a trench beneath between the continents. Sediment from the seafloor gets pushed onto the continents. The continents collide. The ocean floor is completely destroyed and the trench collapses. Sediment accumulates in the trench, and then mountains form. And this is all in that text. So I'm actually going to go through and reread that text one more time, looking for those answers. Before two continents collide, the ocean between them slowly disappears. The seafloor gets subducted into a trench that runs along the boundary between the two plates. As the seafloor is subducted, the two plates scrape against each other, and this causes seafloor sediment to collect in the trench. When the oceanic crust is completely subducted, the trench collapses, and the marine sediment is forced up onto the approaching continents. As the continents collide, the crust of the two plates begin to buckle and fracture. much of the continental crust is thrust upward, rising into peaks that over millions of years form mountain ranges extending the length of the border between the continents. All right, let's put this in order. All right, the first thing that happens really is the seafloor slowly sinks into a trench between continents. That's first. Second, sediment accumulates in the trench. Third, the ocean floor is completely destroyed and the trench collapses. Fourth, sediment from the seafloor gets pushed onto the continents. Fifth, the continents collide. And then finally, mountains form. Question B says the fossils of marine animals and plants are often found at the tops of mountains. Explain how you think this is possible. This happens because the marine sediments that form when the oceanic crusts collide are forced up onto the continents, becoming a mountain range. So where those continents collide, they're going to be folded up into what's called folded mountains, and those marine sediments are found at the very top. All right, let's move on to day 4. All right, day 4 has one vocabulary term. It's subcontinent. This is a large landmass smaller than a continent or a major subdivision of a continent. The Himalayas are a huge mountain range that stretches between Asia and India and provides a dramatic example of colliding continents. About 70 million years ago, the Indo-Australian plate crashed into the Eurasian plate. For the next 20 million years, the Tethys Sea, which lay between Asia and the subcontinent of India, shrank as the two landmasses moved closer together. During this time, the oceanic crust of the Indo-Australian plate was subducted under the continental crust of the Eurasian plate. The Tethys Sea completely disappeared about approximately 50 million years ago as the two continents collided. The Himalayas have been rising steadily ever since. Although they are among the world's youngest mountains, they are also the tallest. Mount Everest, the highest peak of the Himalayas, rises 8,850 meters, 29,035 feet above sea level, and it's still growing. For the questions, write true or false. Today, the continents of Europe and Asia and the subcontinent of India form a single landmass. This is true. The Tethys Sea disappeared about 70 million years ago. That's false. We think it disappeared about 50 million years ago. The Eurasian plate was subducted under the Indo-Australian plate. That is false. It's reversed. The Indo-Australian plate subducted under the Eurasian plate. And then India is a subcontinent of Asia. That is true. For B, is the boundary between the Indo-Australian and the Eurasian plates convergent, divergent, or transform boundary? How do you know? Well, a divergent boundary is where plates are moving away from one another, and these two continents are not, they're colliding. Transform boundaries are where plates slide past one another. They don't lead to mountain ranges or seas disappearing. So this isn't a transform boundary either. This is a convergent boundary. And we know this because the plates, the tectonic plates, are moving toward each other. and they even have collided, which is why they are pushing up into mountains. Hopefully this helped you better understand and complete this assignment. Thanks for watching.